An example of that is a very similar graph to the one that I showed earlier, but now let us say it has 2 delays instead of 1. Right now what is the critical path? It is 2 time units. What is the iteration period bound? The total execution delay dA plus dB is equal to 2, but the number of tokens on that loop is also 2. Therefore, the iteration period bound is 2 by 2 equal to 1. And if I now retime this, what I can get is 1 delay over here, 1 delay over here, and my critical path now becomes equal to 1, which is equal to the IPB. So, this is a simple way by which I can use retiming, right. It is something very similar to the idea of pipelining, but applies for circuits with feedback, right. If I look at this, what have I actually done over here? I have essentially taken this as my cut set. Is it a feed forward cut set? No, because one edge goes from A to B and the other edge goes from B to A, but I have still applied movement of registers across this cut set. Effectively, the way that you can look at it now is, I can choose any cut set, it need not be feed forward alone, it is just that in one direction if I am adding registers, in the other direction I should be able to subtract registers, right. So, in other words, for this direction I do plus 1, in this direction I do minus 1, and that is what has happened, right. The A to B edge which had 0 registers on it, I did plus 1 and it ended up with 1 register. The B to A edge which was going backwards had 2 registers on it, I do minus 1 and it becomes 1 register on it. Okay. So, how is this useful? Very simple. Right now the critical path has reduced from 2 to 1. If this circuit was part of a larger system, there also it is quite possible that moving this register into a different location could have given me an improvement in my critical path. Okay. One last thing before we stop for today's class, one observation that we can make from this transformation that I showed over here. What is the total number of registers that I have over here on my original graph? 1 plus 3 plus 2, 6. What about here? 2 plus 1 on the input plus 1 plus 1 on the output, 5. Okay. So, in other words, the retiming operation does not necessarily preserve the number of registers that are present in the circuit. Why did this happen? Because I had 3 input edges, 2 output edges. So, when I moved a register from the input side to moved a set of registers from the input side to the output side, the required number of registers reduced. I have only 2 output edges. You could potentially make use of this. Let us say that your critical path was no longer your concern, right. You are operating at a stage where speed is taken care of, you are anyway able to meet your speed. Why would you then want to do a retiming of this sort? You can reduce the number of registers, which in turn could translate possibly into a reduction in hardware and therefore reduction of area. So, in other words, the bottom line is this: retiming by itself is just a transformation. All that it says is under what conditions are you allowed to move registers from input of a computational node to the output. If you do it completely on feed forward cut sets, it is a sort of simplified version that is called pipelining and is very commonly used. It can be applied in general for circuits that have feedback as well, provided that these conditions are satisfied, that anything going in one direction, if you are increasing the number of registers, in the opposite direction you need to decrease the number of registers. And at any point in time the number of registers on a given edge cannot become negative. Under those constraints, it is possible to set up complete optimizations. You could either try to optimize the critical path and therefore the speed at which the system operates, or you can try and optimize the total number of registers present in the circuit, which in turn is related to the area occupied by the circuit, or in some cases you might even have some other combination of these, right, some other metric that you are interested in, which is the sort of balancing, where are you able to place the registers, in which part of the circuit do the registers go, and how are you able to use them. So, it is possible to set up different kinds of optimization problems depending on the cost condition that you want to optimize for. The retiming by itself is just the basic transformation, the concept that allows you to do this movement of registers that you can then use systematically.